Properties of radicals. And we're also going to simplify some more complicated radicals using the product and quotient properties. So let's get started. First of all, I want to start off, here's a list of different properties I want to talk about, but I'll give some examples to make it more real. So first of all, let's do some examples to talk about property number one. If you have the square root of x squared, square root and squared just totally cancel out, and that just simplifies to be x. Let's do an example. The square root, by the way, I don't need to write that index. When there's no index written, that means square root. So the square root of 5 squared. Let's think about that. So the square root of 5 squared, that's the square root of 25. The square root of 25 is 5. So the square root of 5 squared, the square root and the squared totally cancels out. Now you might ask, well, what if it's a negative number on the inside? Like the fourth root of negative 3 to the power 4. Okay, think about this for a moment. Negative 3 to the power 4, that's negative 3 times negative 3 times negative 3 times negative 3. That's actually 81, positive 81. The fourth root of 81 is 3. So the fourth root of this term, negative 3 to the power 4, the fourth root to the power 4 cancels, but that negative becomes a positive. That's why they put the absolute value here. So whenever you have an even root, like square roots or fourth roots or sixth roots, that inside negative number will cancel out when you're taking the fourth root of something to the fourth or the square root of something squared. But let's look at the second property. Interestingly enough, if you have a negative number and then an odd power, like cube root of negative 2 to the power 3. So negative 2 to the power 3 is negative 2 times negative 2 times negative 2, which negative times negative is still negative, negative 8. Cube root of negative 8 is negative 2. So in that case, the cube root of something to the power 3, you can take this inside term totally, include that negative number. Okay, let's look at the product property. So the product property, property number 3, is saying if you have the square root of x times the square root of y, you are allowed to go ahead and put those in the same square root of x times y. So for example, if you have the square root of 8 times the square root of 2, we could go ahead and write that as the square root of 8 times 2, which is the square root of 16, which is 4. Okay, similarly, we have the same thing for quotients. So quotients are dividing. So for example, if we have the cube root of 32 divided by the cube root of 4. Now, the cube root of 32 is not a pretty number, the cube root of 4 is not a pretty number, but you can combine those all to be the cube root of 32 divided by 4, which is the cube root. 32 divided by 4 is 8. And the cube root of 8 is a nice number. It's just 2 times 2 times 2. So the cube root of 8 is 2. Okay, those are the properties. And we'll do a few more examples to practice. So first of all, simplifying the square root of 75. I want to break this up into things that simplify better. So what I want to first do is think 75 can be written as just 25 times 3. Okay, 25 times 3, that could just be the square root of 25 times the square root of 3. That's the product property. And the square root of 25 simplifies. It's just 5 square roots of 3. Okay, now you might say, how did I know to break it up into 25 times 3? I mean, I could see it, but other ways you can do it. This is called breaking it up into the product of prime factors. Divide by 2, no. Divide by 3, that's a prime number. 3 goes into 75 25 times, and 25 is just 5 times 5. So I could have written 75 as 3 times 5 times 5. Okay, well, let's do that for the cube root here of 54. Let's start. I'm not sure how to make this more simple. So what I'll do, let's use another color actually. What I'll do is I'll break 54. At least I know a 2 can come out of it. That's a prime number. And then 2 times 27 is 54. Now 2 does not come out of that, but I know 3 does. This is 3 times 9. And 9 can break even farther. 9 is 3 times 3. Now I've sort of pulled the number 54 apart to be a product of prime factors. So instead of writing the cube root of 54, I'm going to write the cube root of 2 times 3 times 3 times 3. Now how does that help us? Well, let's break this up even more using the product property. That's the cube root of 2 times the cube root of 3 times 3 times 3. So that's 3 to the power 3. Now remember, the cube root of something to the power 3 just cancels. So that's the cube root of 2 times cube root of 3 to the power 3 is just 3. Now for our last step, it's usually helpful to put the square root or the cube root at the end. So we're going to say the answer is 3 times the cube root of 2. Okay, let's try the next one. Now notice there's no number here, so that's square root. So I will, first of all, try to break 48 apart, see if we can break it up to see how we can simplify. So 48 is just 2 times 24. 24 is just 2 times 12. 12 is just 2 times 6. And 6 is just 2 times 3. So lots of work to realize that 48 can be rewritten as 2 times 2 times 2 times 2 times 3. So let's go ahead and rewrite this square root, 48x cubed, and we'll pull it apart. Instead of being 48, it's 2 times 2 times 2 times 2 times 3. And even x cubed we can pull apart. That's x times x times x. Now since this is a square root, it's not written, but when there's no index written there, it means square root. If we had items that were squared, meaning groups of 2, they will simplify. So this becomes the square root of 2 squared. That's the first group. We have another group, the square root of 2 squared. We have this group, which is the square root of x squared. And don't forget, we still have all the leftovers, which here is 3x. There's no way to group those in any groups of 2. So each one of these will simplify. The square root of 2 squared is just 2. Another one, the square root of 2 squared is 2. The square root of x squared is x. And the square root of 3x, we can't simplify any further. Last step, 2 times 2 is 4x. Square root of 3x, there's actually no need to write the index. When there's no index written, that means square root. Okay, 2 more examples. They look a little more complicated. In this case, it's going to help us to go in reverse with the product and quotient properties. I'm going to combine this all into one, and I'm going to group together like terms. So I'm going to say 3 times 8. I don't like how I did that. 3 times 8. And then x to the power 1, x to the power 4, and then y to the power 2. 3 times 8. Now again, we want to break this as far apart as we can. So we end up, 8 is just 2 times 2 times 2. So 3 times 2 times 2 times 2. We've got 5 x's, 1 and then 4 more. And then we've got 2 y's. And remember, since this is a square root, every time you see groups of 2, we're going to be able to simplify and take them out of the square root. So we've got the square root of 2 squared, that's just a 2 taken outside. Then we've got the square root of x squared, that's just an x taken outside. the square root of another x squared, that's just x taken outside, and the square root of y squared. And what's left over is the 2, the 3, and the x. 3 times 2 times x. Okay, that looks bad because of the times. I'll just use that. 3 times 2 times x. Okay, and now we simplify. We can combine that. 2x squared y. Square root of 3 times 2 is 6x. Okay, last problem. Again, we can combine and put them all in the same cube root. So we're going to have 250 divided by 2, w6 divided by w2, x4 divided by x1. And that will simplify quite a bit. So we'll have the cube root of 125. This is going to be w6 minus 2 is w to the 4. 6 minus 2 is 4. And then x to the 4 minus 1 is 3. So now if you want to pull 125 apart, 2 doesn't go into it, 3 doesn't go into it, 5 goes into it. 5 goes into it 25 times, and 25 is just 5 times 5. So we can rewrite 125 as 5 times 5 times 5. There's 4 w's here. There's 3 x's here. So every time you see a group of, because we have cube root, every time you see a group of 3 terms, the cube root of something cubed simplifies and you can take it out. So the cube root of 5 cubed is just 5. Let's get a new color. The cube root of w cubed is just w. The cube root of x cubed is just x. And what's left over is the cube root of w on the inside.